So let's see the actual program, how it looks like, right? So we have a number, which we don't know what the number is. Okay, we have no idea, but all we assume is the user has entered a 6-digit number, 6-digit integer. Okay, and we convert that number into an integer and then store it into the variable called number. The number can be any number, we don't know, right? Now the first thing we do is we divide the number by 100,000 and store the value into the variable digit 1. Okay, and then we get the remainder by using the modulo operator and then store the value in a variable called r. Okay, so that gives us our first leftmost digit and the remainder, and we carry on the process. Digit 2 equals r divided by, this time it's 10,000, and then r, we update r by dividing the older value, by taking the modulo, the older value, with 10,000, right? And we carry on 1,000, right? And then 100, and then finally, once we have 2 digits, we'll get the digit by dividing and modulo straight away, right? So if the user entered, let's say the user entered a random number, I don't know, 8 1 6 5 0 0, right? Just random number, anything that the user enters will work as long as it's a 6-digit number, right? So once you write this program, once you run it, it will run for any 6-digit number that you can provide. Okay, so given this number, digit 1 equals the number divided by 1000. So given the number 81650, when you divide this number by 100,000, right, you get 8.16500, right? So this 8 is our quotient because that's the number we get when we do the integer division, right? So the digit 1 has 8 stored in it, and then the remainder is obtained by using the modulo operator, and the remainder in this case is 16500, right? And that value is stored in the variable r, 16500. Okay, now once we are done with that, once we have obtained the quotient and the remainder, what we do is we take the remainder and then divide the remainder by 10,000, right? So the remainder was 16500, right? 16500. When we divide the remainder by 10,000, we get 1.6500, right? And that 1 is stored into the digit 2. So digit 2 has now 1, and the remaining, which is 6500, the remainder is stored into r, right? So r, the variable r, is updated, right? So 6500 is stored in the variable r. So we update the variable r. Okay, the new value of r is equal to the old value of r modulo 10,000, right? Once we get that, right, again we do the same thing for digit 3. So our remainder now is 6500, so 6500, and we divide this number by 1000, right? 1000, and that gives us 6.500, right? And that 6 is stored as digit 3. So digit 3 has the value 6, and the remainder 500 is stored into r, is stored back into r, right? So now r contains 500, and we keep doing this, right? So the remainder was 500, and we divided by 100. So 500 divided by 100 gives you 5.00. That 5 is our 4th digit, right? Digit 4 has 5, and the remainder is 0, right? Remainder is 0. There is no remainder. Okay, now digit 5 equals r modulo 10, right? So it's r is 0, the remainder is 0. Digit 5 is 0 divided by 10. So when you divide 0 by something, what do you get? When you divide 0 by something, you get 0, right? You get 0. Okay, and when you divide 0 by anything, right, the remainder is also 0. Okay, the remainder of a division with numerator 0 is also 0, okay. So in this case the remainder will also be 0, okay. And that's how, no matter what the number is, as long as it's a 6-digit number, you can perform these steps of operations, right, and then print the digits individually. Now if you have a 5-digit number, let's say, you will start not from 100,000 but from 10,000, right? So the set of steps will vary based on how many digits you have in the number, okay. So in the exercise, in the homework assignments, you will have to split a 3-digit number, okay, 3-digit number. So the number of operations that you'll do will vary based on that, okay. So you'll have a fewer number of operations when you have fewer digits in your number, okay. Now the same thing that we did in the last video can be achieved by using the divmod function, right? And remember, divmod takes 2 arguments, okay. It takes the number and another number that you divide it by, right? So you divide number by 1000 and it will give you 2 numbers in return, the quotient and the remainder, right? So here we do the same thing. We take a number, ask the user for a number, and the user may enter a random number, right? For example, let's say, I don't know, 501392, okay. And once you get this number, you do this. You divmod the number by 100,000, right? So when you divmod 501392 by 100,000, you get 5.01392, and this 5 is stored into the variable digit 1, and the remainder, which is 01392, is stored in R, right? Stored in a variable called R. So R has the value 01392. Now in the next line, we do a divmod again. So we divmod R by 10,000 and then store the value in digit 2 and R, right? So when you divmod R with the previous value, which is 01392, when you divide this number by 10,000, you get 0.1392, and that 0 is stored into digit 5, and the R 1392, this value is used to update the variable R. So the new value of R is 1392, okay. And then again we divide 1392, the new value of R, by 1000. So 1392 divided by 1000 gives us 1.392, and we save that value 1 into digit 3. So digit 3 gets 1, right? And save the remainder into the variable R, right? So we update the variable R with this value 392. That's my new R, new remainder, right? And then again in the next line we divide this new remainder by 100. So 392 divided by 100 gives us 3.92. Take this 3, save it into digit 4, right? And take the remainder and use it to update the value, the variable R, right? So R now has 92. Finally, you divide 92 by 10 and you get 9.2. You take the 9, save it in digit 5, right? And essentially you can take the 2, which is the last digit, and save it in digit 6. So here what I did was, let me clear the screen for you. So I said digit 5 R equals this. By this time R is a 2-digit number. It's a 2-digit number, right? Because every time we reduce the number of digits in the remainder, right? So it's a 2-digit number. Let's say it's I don't know, 45 or something, right? So when you divmod 45 by 10, what you get is the quotient is 4 and the remainder is 5, right? Now if it's a 2-digit number, your quotient would be the leftmost digit and your remainder is the rightmost digit, right? So I could have said, instead of these 2 lines, I could have said digit 5 comma digit 6, equals div mod equals div mod r comma 10, and that's the exact same thing as this. Okay, but I could have said this as well. Okay, whichever one you choose doesn't matter, it's the same thing, right? So this is another way of performing the same task or running the same program that we ran before, except this is slightly more neater, cleaner, right? So instead of doing a division and a modulo every other line, you use div mod to get both results in the same line. Okay, so this is just a shortcut of the previous approach. Okay, but essentially they do the same thing. Okay,